Hi, this is Lance from LangChain. We're starting a new series called RAG from Scratch that's going to walk through some of the basic principles for RAG and kind of build up to advanced topics. So one of the main motivations for RAG is simply that LLMs haven't seen all of the data that you may care about. So like private data or very recent data would not be included in the pre-training runs for these LLMs. And you can see here on the graph on the x-axis that
in this course, Lance Martin will teach you how to implement RAG from scratch. Lance is a software engineer at LangChain, and LangChain is one of the most common ways to implement RAG. Lance will help you understand how to use RAG to combine custom data with LLMs.
Hi, this is Lance Martin. I'm a software engineer at LangChain. I'm going to be giving a short course focused on RAG, or Retrieval Augmented Generation, which is one of the most popular kind of ideas and applications in LLMs today. So really the motivation for this is that most of the world's data is private, whereas LLMs are trained on publicly available data.
Hello everyone, Daniel here. In this video tutorial, we're going to start from a blank notebook and end with a full Retrieval Augmented Generation pipeline, or RAG pipeline, from scratch. And best of all, it's going to run on our local machines, all to showcase the power of AI on RTX. Have a look at that GPU. NVIDIA have been so kind to send me an RTX 4090 GPU, so shout out to Mark, thank you so much for that. Now, what this means is that if you have a PC with an NVIDIA GPU, you've got a gym. No, I'm joking. It means you've got a machine that's incredibly capable of AI workflows. So I've got all the code here on GitHub. We're going to write this line by line together in this video. Check the link in the description for that. But it's also to celebrate the upcoming NVIDIA GTC conference, which is happening from March 18 to 21. But if you're watching this in the future and it's already happened, there's a heap of sessions that are going to be virtual. So it's happening in San Jose, California. I live in Australia, so I'm going to be attending virtually. I've got 3 sessions lined up that I'm looking forward to. This is Retrieval Augmented Generation, an overview of design systems. So this is similar to the pipeline that we're going to be building in this video. There's some NVIDIA software in here, TensorRT LLM. We don't explicitly cover that, but that's what I want to learn more, potentially for a future video. So let me know if you want to see that. And then I also have saving trees in forests all over the world using AI, a really cool application to identify 600 different species of trees on a mobile phone with a macro lens. That's so cool to me. And then we have here, building a deep learning foundation model via self-supervised learning, which is a really powerful technique that what large language models use to learn. They use self-supervised learning to learn from large corpuses of text, but this is bringing it to computer vision. So once again, all the code's on GitHub. The links will be in the description. Follow along if you'd like to build your own very own RAG pipeline from scratch, running on your own PC. I might have to move this to the floor because it is quite loud running here. If you have any questions, leave a discussion on the GitHub page or a comment below, and let's build.
Hello. Welcome to the simple local RAG tutorial. Now, we're going to rebuild this workflow and we're going to have it run all locally on our own GPU. And if you want the materials for this, they're on the GitHub, so I'll put that link in the description. And if you want to run it in Google Colab, maybe you don't have a local GPU available, you can click on the link here. It's all in the GitHub. This same workflow that we're going to go through will all run in Google Colab. So let me just jump into what we're going to do. You can use this notebook here as a reference, but we're going to code this whole thing up from scratch. There's some information here. What is RAG? Why RAG? If you've never heard it, we're going to be saying RAG a lot during this video. What kinds of problems can RAG be used for? Why local, key terms, what we're going to build, all that sort of stuff, all the code and explanations are in this notebook. A lot of vector outputs there, so that's where all those numbers come from. They're from our embeddings, but we're going to get to that. I'm just giving you this so you can use it as a reference because we're going to code all of this up from scratch. So let's jump into an example workflow. And by the way, we're going to take this quite slow. We're going to write every line ourselves. So if you have any questions or issues, leave a comment on the video or a discussion on GitHub or an issue if there's something wrong. If you want to get set up, all the instructions are here, but we're just going to go through this step by step. So, what is RAG? Well, RAG stands for Retrieval Augmented Generation. And I've stolen this image or this flowchart from NVIDIA's blog. So they have a great blog post, which is Demystifying RAG 101, and that's kind of what I've based this workflow off, except we're not using a framework. We're going to be writing all of it ourselves. We're not using Llama Index or LangChain, which are two great frameworks, and they can help to process these workflows, but we're going to see what it looks like just to do with Python and PyTorch and transformers and whatnot. And then in that way, in the future, if you'd like to use LangChain or Llama Index, well, then you know how to do it yourself. So that's sort of what we're going to be building. If you want to read more, the link to that is available. I'll link this little whiteboard that I'm using as well. But let's dive into it. So, what are we going to build? Well, we're going to break it down into two major parts. The first part is document pre-processing and embedding creation. And the next part is search and answer. But before I jump into this flowchart, we might as well break down what RAG is. And so I've set up my computer to already go through the setup steps. So if you go to the GitHub, I've gone through these steps, git clone, and now I'm using Python 3.11 on a Windows 11 machine with an NVIDIA RTX 4090. So that NVIDIA have so kindly given me to create this video in partnership. So there we go. There's an NVIDIA GeForce RTX, but this should work on almost any local NVIDIA GPU. So, of course, the RTX 4090 at the time of recording is one of the best ones you can buy from a consumer level, but it should work on most modern NVIDIA GPUs. And we put some code in there, so if you've got an older GPU with less memory, it should still work. And we'll discuss that later on when we get into model usage. So I've gone through these setup steps, and that's what I've got here. Excuse me, I'm still getting used to Windows. I've created an environment, I've activated it, I've installed the requirements, and if you run into any issues setting up the requirements, I put some notes here. But two things that we can do if we want to run locally. We can use VS Code, and so I can just type in code dot, and that'll bring us up here. This is the same repo, just running on my local computer. And then if you want to start a new notebook here, we can just go simple local rag, and I'm going to call it .video, IPython notebook, and then we can just start from here. Import torch, shift and enter. We'll select our Python environment. We can run it there. So import torch. So there we go. However, I personally have found, and maybe I'm doing something wrong because I'm not used to using Windows, that VS Code kind of lags a little bit for me when I have a large notebook. Maybe I'm doing something wrong. If you know about this, please let me know. So what I'm going to do, instead of pressing code dot, I'm going to start with a Jupyter notebook. So Jupyter notebook. But the same process will run whether you're using a VS Code notebook, which should technically be the same as using Jupyter. So now I'm using a Jupyter server, which has the same files that my VS Code setup has. But I'm just going to use Jupyter. If you want to use VS Code, you can do that as well. So let's jump into this. Dismiss. Oh, what's going on here? Oh, I haven't saved it here, of course. That's an interesting error. See, I'm going to leave some of the errors in here, you know. So let's see if it opens up now that I've saved it. Okay, there we go. We get torch. And I'm going to zoom in a little bit there. That should be good. Okay, so I know that was a bit of an intro, but again, all I've done here is I've gone through the setup steps. I've just done this in the terminal, git clone, cd into simple local rag, created an environment, launched it, and then installed the requirements in that environment. Done here. If you'd like to see a dedicated setup video to this, please let me know and I can make one of those. But now I'm at this stage. I've just gone Jupyter Notebook and we are in like the kid in the tree. All right, so let's create a title for this. So we want to create and run a local RAG pipeline from scratch. Now, of course, it won't be 100% from scratch. We won't be training any embedding or LLM models here, but we will be using them. So let's define what is RAG. What is RAG? So RAG stands for Retrieval Augmented Generation. You may have been seeing this quite regularly in the world of LLMs and generative AI. Essentially, the goal